Hello everyone. This video is about solving right triangles. Now, what is a right triangle? A right triangle is a triangle that contains the right angle 90 degrees. On the figure on your screens, the right angle here is angle C, while the other angles are A and B. Now, these angles are represented by uppercase letters. Now, the lengths of the opposite sides are denoted by lowercase letters, small a, small b, and small c. Now, if we consider angle A as our angle theta, then the side opposite angle theta is called the opposite side, while the side adjacent to angle theta is called the adjacent side, while the side opposite the right angle is called the hypotenuse. Now, the relationship of the lengths of the sides is given by the Pythagorean theorem, a squared plus b squared equals c squared. Now, also, the sum of the interior angles of a triangle is equal to a plus b plus c is equal to 180 degrees. Now, since in this triangle, the angle c is the 90 degrees, then we have a plus b plus 90 degrees is equal to 180 degrees. So this means that if we transpose the 90 degrees from left side to right side, then we have a plus b is equal to 180 degrees minus 90 degrees is 90 degrees. So in a right triangle, if we want to solve for either the angle A or the angle B, we can just subtract the given angle from 90 degrees to get the measurement of the other angle. Now, we also use the following relationships in solving for the opposite side, adjacent side, and the hypotenuse. The sine theta is equal to the opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Now, we can also make use of the other three trigonometric functions by just getting the reciprocals of sine, cosine, and tangent. So in here, cosecant theta is the reciprocal of sine, and that gives us hypotenuse over opposite. Secant of theta is the reciprocal of cosine, and that gives us hypotenuse over adjacent, while cotangent theta is the reciprocal of tangent, and that gives us adjacent over the opposite side. So in our examples here, we will use a right triangle with C as the right angle. So let us try to solve the right triangle given that the length of side A is 6 units and the measurement of angle B is 40 degrees. So let's label them on the right triangle figure. So we have here 40 degrees and we have here 6 units. So let's use this as our angle theta. Now, since P is already 90 degrees and B is 40 degrees, we can easily solve for the angle A. So the angle capital A is equal to 90 degrees minus the angle B, and that's going to be 90 degrees minus 40 degrees, which is equal to 50 degrees. So the angle A here is 50 degrees. Okay, now, we have solved all the angles or all the interior angles of the right triangle. So now we solve for the lengths of side C and side B. So if we want to solve for side B, it depends on the angle that we are using. No? So the formula for small b um, will be different if we use either the 40-degree angle or the 50-degree angle. So if we try to solve for side B using the 40-degree angle, then that means side B here is the opposite side, while side A is the adjacent side, and side small c is still the hypotenuse. But if we are using the 50-degree angle as our angle theta, then side small b will be the adjacent side, and side small a will be the opposite side. So you can use any of those. Okay, but we're going to use here 40 degrees as our angle theta. So if you want to solve for small b, then we refer to this as the opposite side. And then we have the value of the adjacent side, which is 6. So we're going to use tangent of 40 degrees, which is equal to the opposite side, which is small b, divided by the adjacent side, which is 6 units. So to solve for d, you multiply both sides by 6, and we get 6 times tangent of 40 degrees is equal to small b. So using our calculators, we multiply 6 by tangent 40 degrees, but make sure that your calculator is in the degree mode and round off your final answers to two decimal places. So that's going to be 5.03 units. So this is 5.03. Now, the only thing left to solve is the value or the length of side C. So since we already have the values of small a and small b, we can make use of the Pythagorean theorem to solve for small c. So we know that c squared is equal to a squared plus b squared. And in this case, c is equal to the square root of a squared plus b squared. So that gives us the square root of 6 squared plus 5.03 squared. So again, using our calculators and rounding off the final answers to two decimal places, we get 7.83 units as the value of small c. So that solves the right triangle. Okay, now let's have another problem. So again, we're given with a right triangle ABC with angle C as the right angle. But in this case, we're given with the measurement of angle B, which is 72 degrees, and the value of small d, which is 6. So what we have here is a triangle wherein the length of the opposite side to 72 degrees is 6. So again, just like in the previous problem, we can solve for the angle A by just subtracting 72 degrees from 90 degrees, and that's going to be 18 degrees. So angle A is 18 degrees. Okay, now let's try to solve for um, small a, but this time let's use the angle A, which is 18 degrees. Let's use this as the angle theta. So what we have here is uh, the adjacent side is given, and this is the opposite side. So A is the opposite of 18 degrees, opposite side of 18 degrees, and 6 units is the length of the adjacent side to 18 degrees. So that means we're going to use sine of 18 degrees is equal to, I'm sorry, tangent of 18 degrees, which is A, opposite side is A, over the adjacent side, which is 6. So in this case, we can multiply again with both sides of this equation by 6. And that gives us A is equal to 6 times tangent of 18 degrees. And that gives us 6 times tangent of 18 degrees. 6 times tangent of 18 degrees is equal to 1.95 units. So that's the value or the length of side A. And then next is we will solve for the length of side C. So again, by the Pythagorean theorem, we can make use of the formula C is equal to the square root of A squared plus B squared. And that's equal to the square root of 1.95 square plus 6 square. So that's going to be, let's use our calculator, 6.31 units. So that's the length of the sides. Now, we can also solve the problem, but instead of solving for A first, no, instead of solving for A first, we can solve for um, the length of the side C. So if we're using 18 degrees as our theta, then we can make use of adjacent and the hypotenuse. So that's going to be cosine of 18 degrees is equal to the adjacent side to 18 degrees is 6, and then divided by the hypotenuse, which is 2. So if we use this equation, okay, we can multiply um, both sides by c. And this gives us c times cosine of 18 degrees equals 6. And then dividing both sides by cosine 18 degrees will give us c is equal to 6 over cosine of 18 degrees. So if we divide this by cosine of 18 degrees, the result should also be 6.31 units, which is what we got in the earlier solution. So in that case, we have the angles, we have the length of the side C and the length of the side B, but we don't have the length of side A. So if you want to solve for side A, then we know that A square is equal to C square minus B square. So this is derived from the relationship of ABC in the Pythagorean equation. So A is equal to the square root of C square, which is 6.31 square, minus B square, which is 6 square. And that gives us 1.95 as the value of A, which is what we got also from the earlier um, solution. Okay, but the approach is different because we have to make sure that we're using the correct sides and the correct relationship of those sides. Okay, next is let's try to solve for C, the right triangle with the angle C as the right angle, but with the given information that side small c is 41 units and the measurement of angle A is 20 degrees. So let's try to use again the relationship of the interior angles. So since we have A and C already, so we can solve for the angle B by just subtracting angle A from 90 degrees. So that gives us angle B is equal to 70 degrees. Now let's try to use angle A as the angle theta, and small a is the opposite of the angle theta. B is the adjacent side, and small c is the hypotenuse. So if we want to solve for the opposite side, we can make use of the length of the hypotenuse and the angle 20 degrees using sine of 20 degrees is equal to the opposite side, which is A, over the hypotenuse, which is 41. So multiplying both sides by 41, this gives us A is equal to 41 times sine of 20 degrees. So using our calculators, we will get 14.02 units as the value of A. So since we already have A, small a and small c, we can make use of uh, the Pythagorean relationship. B square is equal to c square minus a square, and that gives us b is equal to the square root of c square, which is 41 square, minus a square, which is 14.02 square. So again, using calculators, we get 38.53 units as the length of sides value. And that solves the right triangle. Okay, another example would be solve the right triangle ABC with angle C as the right angle, and length of side C is 7 and length of side B is equal to 4. So in here, we do not have enough information to solve for either the angle A or the angle B. So if we just set, let's say, a specific angle as our theta, let's suppose that that is angle A. So if angle A is our theta, then the adjacent side is small b and the hypotenuse is small c. So by the relationship of this adjacent and hypotenuse, so we can make use of cosine of angle A, which is adjacent, which is 4 over the hypotenuse, which is 7. Now, from this equation, we can solve for the angle A by making use of the inverse cosine of angle A. Inverse cosine of 4 over 7, rather. So A is equal to inverse cosine of 4 over 7. So using our calculators, we will get 55.15 degrees as the value of, or the measurement of angle A. So this is 55.15 degrees. So since we already have angle A, we can solve for the angle B, which is 90 degrees minus 55.15 degrees. So 90 minus 55.15 is 34.85 degrees. And the only thing left to solve is the length of side A. So in this case, if we are going to use again 55.15 degrees as our angle theta, the side small a is the opposite side, and we can make use of either the adjacent side or the hypotenuse. So in this case, let's use the hypotenuse. So we can use sine of 55.15 degrees, and that's equal to the opposite side, which is a, over the length of the hypotenuse, which is 7. So multiplying both sides by 7, okay, will give us a is equal to 7 times sine of 55.15 degrees. 7 times sine of 55.15, and that is 5.74 units. However, we can also make use of the Pythagorean equation. So we can solve for a using the square root of c squared minus b squared. And that's going to be 7 squared minus square root of 7 squared minus 4 squared, which is 5.74 also. So we have to get the same length. Okay, whatever relationship we use to solve for a particular unknown quantity in solving right triangles. Okay, now let's go to the application of right triangle. So usually for applications, we define what is the angle of elevation and the angle of depression. So the angle of elevation is the angle formed by the line of sight with the ray going to a point above the ground. So let's say you are at the ground, and then this is your line of sight, and then you're looking at a point, above the ground. So the ray, going to that point, and your line of sight, will form the so-called angle of elevation. Now, the angle of depression is the angle formed by your line of sight and the ray going to a point on the ground. So let's say you are on top of a building and this is your line of sight, and then you're looking at a point on the ground. So the ray going to the point on the ground and your line of sight will form the angle of depression. Now, this angle of depression, is actually equal to the angle formed by the ground and this ray. Okay, so let's try to answer the following problems. So a ladder rests against a building at a point that is 63 feet from the ground. So let's consider that this is the building and this is the ladder. Okay, and then the um, a ladder rests against a building at a point that is 63 feet from the ground. If the ladder makes an angle of 47 degrees with the ground, find the length of the ladder. So if this is the angle 47 degrees, if the angle that's the angle created by the ladder and the ground, and then the 63 feet here uh, is the distance of the bottom of the ladder and the bottom of the building. So this is 63 feet. Okay? And then we need to know the length of the ladder. So if we are going to use this figure, and if we use angle theta as 47 degrees, the adjacent side is given with 63 feet, but we don't have the value or the length of the hypotenuse, which is the length of the ladder. So that means we're going to use the cosine of 47 degrees, which is equal to the adjacent side divided by the um, hypotenuse. So let's call this hypotenuse as our x. And then solving for x, now we get x is equal to 63 over cosine of 47 degrees. And that's going to be equal to 92.37 feet. So that's the length of the ladder. Okay, and then let's have another example. A rectangular lot is 102 feet by 296 feet. Find the length of the diagonal and the angle it makes with the longest side. So based on the measurements of the rectangle, now we can say that this side is 102 feet. This side is also 102 feet, but the other side is 296, and the side parallel to it is also 296 feet. So we want to know the length of the side and the angle that it makes with the longest side. So the angle that it makes with the longest side will be this angle. So if this is angle theta, that's angle theta. Okay, we can make use of the opposite side, which is 102 over the adjacent side. So it's going to be tangent of theta is equal to the opposite side over the adjacent side. So to solve for theta, we can make use of the inverse tangent. of 102 over 296. So using our calculators, that's going to be 19.01 degrees. So that's the angle created by the diagonal of the rectangle and its longest side. Now, in order to solve for x, so since this is a right triangle here, we can make use of the Pythagorean theorem. So since this is the hypotenuse, then that's going to be x is equal to the square root of 102 square plus 296 square. And that gives us, okay, that's going to be 313.082. So that's the length of the diagonal. Okay, and then let's have the following problem. The angle of depression of a searchlight to its target is 58 degrees. So in this case, since it's angle of depression, we assume that the searchlight is, of course, it's above the ground. So this is the searchlight. That's the position of the searchlight. And then the target is on the ground. So the angle theta or the angle of depression is the angle formed by the line of sight of the searchlight and the ray going to the target. So that's 58 degrees here. How long is the beam of light? So this is the beam of light. Let's call it x. If searchlight is 20 feet above the ground. So if you are going to draw an imaginary line from the searchlight going to the ground, that's going to be 20 feet. And if we draw another line at the ground, a line at the ground, now that forms a right triangle. Okay, now, since the angle of depression is 58 degrees, now by something that you learned in geometry, that this angle is equal to 58 degrees as well. So if we are solving for x, which is the hypotenuse, and we're given with the length of the adjacent side to 58 degrees, then we can make use of cosine of 58 degrees, which is equal to the adjacent side, which is 20 feet, over the hypotenuse, which is x. And then solving for x, we get 20 over cosine of 58 degrees. So that's going to be 20 divided by cosine of 58, and that's going to be 37.74 feet. So that's the length of the beam of light. So that's the final answer to this problem. And then finally, from a height of 38 meters above sea level, two ships are sighted due west. The angles of depression are 53 degrees and 28 degrees, respectively. How far apart are the ships? So, from a height of 38 meters above sea level, okay, two ships are sighted due west. So, this is the west direction. Okay, and then the angles of depression are as follows. So, if we form the line of sight here, this angle is the angle of depression and its measurement is 53 degrees. So that means this angle here is 53 degrees as well. Okay, now, um, there's another angle of depression here, which is 28 degrees. And that means that this is the angle 28 degrees, from something that you learned in geometry. And then these are the positions of the two ships. Ship 1 and ship number 2. So what we want to know is the um, distance of these two ships. So we want to know the length of this distance. Okay, now from this illustration, we can separate this illustration into two right triangles. Okay, so the first right triangle will be the one with the 53 degrees. So that means this one is 38. And then the other right triangle will be the one with the 28 degrees. And this is the 38 meters. But what we want to know is this particular length here. So if we try to denote this by y, this thing will be y, and then this thing will also be y. So let's try to solve for y first before we solve for x. So in this triangle here, the relationship is tangent of 53 degrees is equal to the length of the opposite side over the length of the adjacent side. So that gives us y is equal to 38 over tangent of 53 degrees. And using our calculators, that's going to be 38 divided by tangent of 53 degrees, which is 28.64 meters. So that means this thing here is 28.64 meters. Now, in order to solve for x, we again make use of the tangent relationship. So tangent 28 degrees is equal to opposite, which is 38, over the length of the adjacent is x plus 28.64. So if we want to solve for x, now we multiply both sides by x plus 28.64, and that gives us x plus 28.64 multiplied by tangent 28 degrees is equal to 38. And then distributing the tangent, now we get x times tangent of 28 degrees plus 28.64 multiplied by tangent of 28 degrees is 15.23 equals 38. And then if we transpose 15.23, we get x tangent of 28 degrees is equal to 38 minus 15.23, which is 22.77. And then dividing both sides by tangent 28 degrees, that's going to be 22.77 divided by tangent of 28 degrees, which is 42.82 meters. So that's the final answer. That's the distance between the two ships. So this ends the video about solving right triangles. So I hope that you learned on how to solve right triangles and how to apply them. And thank you for listening.